Good morning, students. In this video today I'll discuss about nitric acid, HNO3. Chemical formula of nitric acid is HNO3. Its molecular mass is 63. It is a covalent compound. It is also known as aqua fortis, that is strong water, because it can react with nearly all metals, and it can even dissolve silver, which does not dissolve in other acids. Okay, so that is why nitric acid is also known as aqua fortis. Now see the lab preparation of nitric acid. Preparation of nitric acid in laboratory. Lab preparation. Nitric acid is obtained by distilling concentrated sulfuric acid with potassium nitrate or sodium nitrate. Okay, when sodium nitrate or potassium nitrate is heated with sulfuric acid, nitric acid is obtained. A mixture of equal parts by mass by weight of potassium or sodium nitrate and concentrated sulfuric acid is heated gently to 180 to 200 degrees Celsius in a glass retort. In this reaction, sulfuric acid is a non-volatile acid, and sulfuric acid produces a volatile nitric acid on reacting with potassium or sodium nitrate. On reacting with sodium or potassium nitrate. Okay, so chemical equation is given. Chemical reaction sodium or potassium nitrate, that is KNO3 or NaNO3, plus sulfuric acid. Temperature required is below 200 degrees Celsius. Okay, below 200 degrees Celsius. If potassium nitrate is used, then you will get potassium hydrogen sulfate and nitric acid, and if sodium nitrate, that is NaNO3, that is used, then you will get sodium hydrogen sulfate and nitric acid. This is the lab preparation of nitric acid, reaction between potassium or sodium nitrate and sulfuric acid, concentrated sulfuric acid. In this reaction, a non-volatile acid produces a volatile acid. Okay. Now the method of collection of nitric acid. The vapor of nitric acid are condensed to light yellow liquid by chilling the receiver with running cold water. Here one note is given that pure nitric acid is a colorless, but the acid obtained in laboratory is slightly yellow color. Pure nitric acid is colorless, but the acid obtained in laboratory is slightly yellow, and this yellow color is due to dissolution of reddish brown color nitrogen dioxide in the acid. This yellow color is due to the dissolution of reddish brown colored nitrogen dioxide in acid, and this nitrogen dioxide is produced due to thermal decomposition of nitric acid. Thermal decomposition of nitric acid due to formation of NO2 gas by thermal decomposition of nitric acid. Nitric acid obtained in laboratory is slightly yellow color. Okay, because of NO2 gas. NO2 is a reddish brown gas. Okay, and it is obtained when it is obtained by thermal decomposition of nitric acid. Now see how to remove this yellow color of nitric acid. Two methods is given. One is if dry air or carbon dioxide is bubbled through the yellow acid, the yellow color of nitric acid turns colorless, because carbon dioxide or dry air drives out NO2 from warm acid, which is further oxidized to nitric acid. And second method, by addition of excess water. Nitrogen gas dissolve in water, and thus the yellow color of nitric acid is removed. Okay, so two methods of removal of yellow color from nitric acid is given. Okay. Now see the precautions. Which precautions you have to take in the lab preparation of nitric acid? First, all glass apparatus is used because nitric acid vapor attack the rubber and cork. All glass apparatus is used in laboratory preparation of nitric acid because nitric acid vapor attack rubber and cork. Second precaution, concentrated hydrochloric acid is not used in place of concentrated sulfuric acid. In laboratory preparation of lab preparation of nitric acid, concentrated hydrochloric acid is not used because hydrochloric acid is volatile acid and hence nitric acid vapor will carry hydrogen chloride HCl hydrochloric acid vapor because the nitric acid vapor produced in the laboratory will carry hydrogen chloride vapor because HCl is a volatile acid, and that is why concentrated HCl is not used in place of concentrated sulfuric acid. And third precaution, the temperature of the reaction should not exceed 200 degree. You have to control the temperature. You have to maintain the temperature below 200 degree because sodium sulfate formed at higher temperature at more above 200 degrees Celsius. The sodium sulfate formed at higher temperature forms a hard crust which stick to the wall of the retort, and it is difficult to remove although the yield of the nitric acid is higher. So temperature should not exceed 200 degrees Celsius. Okay, so we have to maintain the temperature below 200 degrees Celsius. Above 200 degrees Celsius, the reaction becomes NaNO3 plus NaHSO4 implies Na2SO4 plus HNO3. This sodium sulfate formed at a temperature above 200 degrees Celsius forms a hard crust which stick to the wall of the retort, and it is difficult to remove. Okay, so below 200 degrees Celsius you have to heat. At higher temperature may damage the glass apparatus, and decomposition of nitric acid can also occur. Okay, and at higher temperature above 200 degrees wastage of fuel it is. Okay, so this precaution you have to control. You have to take these precautions in laboratory preparation of nitric acid. Okay, now see industrial preparation of nitric acid, that is manufacture of nitric acid. The process is Oswald process. It is a 3-step process. Oswald process of preparation of nitric acid in industry. 3-step process. The first step is known as catalytic oxidation of ammonia in catalytic chamber. In catalytic chamber, ammonia gas is heated with oxygen gas with air in presence of platinum catalyst at 800 degrees Celsius. In first step, nitric oxide is formed. Okay, so this reaction occur in catalytic chamber. A mixture. So first step is catalytic oxidation of ammonia. Step 1 of Oswald process, catalytic oxidation of ammonia. A mixture of dry air and dry ammonia. A mixture of dry air, that is oxygen, and dry ammonia in the ratio of 10:1 by volume is first compressed and then passed into the catalytic chamber containing platinum catalyst at above 800 degrees Celsius. So when ammonia reacts with oxygen in presence of platinum catalyst at 800 degrees Celsius, nitric oxide is formed. Nitric oxide, NO, is formed. NO plus water. The chemical equation of the first step is 4NH3 plus 5O2 implies, above the arrow you have to write platinum catalyst and 800 degrees Celsius, and the products are 4NO plus 6H2O plus heat. This is the exothermic reaction, and the heat evolved maintains the temperature of the catalytic chamber. Now in second step, after cooling this nitric oxide produced, in second step nitric oxide is oxidized to nitrogen dioxide. Okay, so step 2, oxidation of nitric oxide in oxidation chamber. Oxidation of nitric oxide in oxidation chamber. In this oxidation chamber, nitric oxide combine with oxygen to form nitrogen dioxide above 50 degrees Celsius. So in first step nitric oxide is formed. In second step, this nitric oxide reacts with oxygen with air at 50 degrees Celsius to form nitrogen dioxide. So 2NO plus O2 implies, above the arrow you have to write temperature 50 degrees Celsius, and the product is 2NO2. 2NO plus O2 implies 2NO2. That is conversion of nitric oxide to nitrogen dioxide. And the last step is adsorption of nitrogen dioxide in water. This is the final step of Oswald process. That is adsorption of nitric oxide NO2 in water. In this step, nitrogen dioxide gas reacts with oxygen and water to form nitric acid. Okay, this is this step in adsorption chamber, adsorption tower. Okay, in adsorption tower, nitric or nitrogen dioxide reacts with water and oxygen to form nitric acid. Okay, so and the nitric acid obtained at the bottom of the adsorption tower is concentrated above 50%, and this 50% nitric acid further distillation gives 68% nitric acid, and the acid is concentrated nitric acid. This 68% nitric acid is concentrated nitric acid, which is used in laboratory. Now on further distillation of 68% nitric acid, you can prepare 98%, that is fuming nitric acid. Okay, so nitric acid up to 98%, that is fuming nitric acid, is obtained by distilling 68% nitric acid over concentrated sulfuric acid. So flowchart of Oswald process is given here. You can see in first step oxidation of ammonia to give nitric oxide in presence of platinum catalyst and temperature 700 to 800 degrees Celsius. In second step, after cooling, nitric oxide reacts with oxygen to form nitrogen dioxide. And in third step, in adsorption tower, nitrogen dioxide reacts with water and oxygen to form nitric acid, HNO3. Okay. Now see some physical properties and chemical properties of nitric acid is given. Nitric acid is a colorless liquid, and it has suffocating smell, and it is acidic in nature. And chemical property mainly important, chemical property of nitric acid. Nitric acid, it is acidic in nature. It turns blue litmus red, and it turns methyl orange pink, and phenolphthalein remain colorless in nitric acid. Reaction of nitric acid with alkalis. As nitric acid is acidic in nature, it will react with alkali to form salt and water. It will form alkali, that is base, to give salt and water. Like nitric acid reacts with copper oxide. Copper oxide is metallic oxide, it is a base. Nitric acid is acid to give copper nitrate, that is salt and water, H2. When sodium hydroxide reacts with nitric acid, it will give sodium nitrate and water, salt and water. Okay. Similarly, when metal carbonate or metal bicarbonate, NaHCO3 or Na2CO3 or CuCO3, when these metal carbonates react with nitric acid, you will get salt, water and carbon dioxide. Okay, for example, when calcium carbonate reacts with nitric acid HNO3, you will get calcium nitrate, water and carbon dioxide. Next is reaction of nitric acid with action of nitric acid on non-metal. This is oxidizing property of nitric acid. Oxidizing property of nitric acid. Nitric acid is a strong oxidizing agent. Okay, it can oxidize some non-metals like carbon, sulfur. So when carbon, sulfur, these non-metals react with nitric acid, you will get nitrogen dioxide gas, water vapor. Okay, when carbon reacts with nitric acid, you will get carbon dioxide, water vapor, and nitrogen dioxide. When carbon reacts with nitric acid, you will get carbon dioxide, water vapor, and nitrogen dioxide. When sulfur reacts with nitric acid, you will get sulfuric acid, not sulfur dioxide, it is sulfuric acid, water and nitrogen dioxide. Water and nitrogen dioxide is common in both reaction. Okay, water and nitrogen dioxide. So when sulfur reacts with nitric acid, S plus 6HNO3 implies H2SO4, sulfuric acid, water and nitrogen dioxide. Action of nitric acid on metals. Nitric acid reacts with metals like zinc, aluminium in three different ways. Okay, so when nitric acid is cold and dilute, when nitric acid is cold and dilute, nitric acid oxidizes metal to metal nitrate and nitric oxide is obtained. So reaction between nitric acid and nitric acid with copper, zinc, iron, with these metals, you will get copper nitrate, nitric oxide, okay, and water. So Cu plus HNO3 implies CuNO3 whole twice plus H2O plus NO. Zinc plus HNO3 implies ZnNO3 whole twice plus H2O plus NO. Okay. But when nitric acid is hot and dilute or concentrated nitric acid, it is also known as hot dilute nitric acid. When nitric acid is concentrated, then nitric acid reacts with copper, zinc, iron with this metal to give copper nitrate or zinc nitrate or iron nitrate and nitrogen dioxide, not nitric oxide. Okay, when nitric acid is cold and dilute, then the products are metal nitrate, water and nitric oxide. When the nitric acid is concentrated or hot and dilute, then the products are metal nitrate, water and nitrogen dioxide. These two are important reaction. Okay, so now see, one term is given, aqua regia. Aqua regia. What is aqua regia? Aqua regia is a mixture of concentrated nitric acid and hydrochloric acid. 3 parts of hydrochloric acid when mixed with 1 part of nitric acid, 1 volume nitric acid and 3 volume hydrochloric acid, and this mixture is known as aqua regia or royal water. Okay, aqua regia. It can dissolve different noble metals like platinum, gold easily. Okay, because the mixture of nitric acid and hydrochloric acid produces a nascent chlorine, highly reactive chlorine, and this highly reactive chlorine dissolves non-reactive metals like platinum, gold easily. Okay, and the last use of nitric acid is not required according to the syllabus. And last portion, test for nitric acid. Test for nitric acid. Concentrated nitric acid gives brown fume on heating. So it is one test of nitric acid due to formation of brown, reddish brown nitrogen dioxide gas. Nitric acid gives brown fumes. Okay, and brown ring test is the main test of nitric acid. When mixture of nitric acid and when mixture of ferrous sulfate and sulfuric acid, when the mixture of ferrous sulfate and sulfuric acid, concentrated sulfuric acid, is added to nitric acid solution, you will get a brown ring formation between the you will get a brown ring formation in the middle of two solution. Okay, and this is the main test of identification of nitric acid, brown ring test. when a mixture of ferrous sulfate and concentrated sulfuric acid is added into the nitric acid solution or nitrate salt solution, you will get a brown ring formation. Okay. And use of nitric acid is not given. Thank you, students.